Hi friends, happy to meet you through this 13th part of NEET Series 2020. Let's learn about some relative acidic strength of the organic compounds. Okay, I strongly suggest you to pause the video, work out, find the answer and check your solution. So the first problem is the correct order of acidity of hydrogens is, the right answer is B. Right answer is B. It's because if this hydrogen is lost, then this compartment, this carbon will get negative charge. That makes this compartment an aromatic one. Whereas if this hydrogen is lost, then this carbon will get negative charge. That makes this compartment an anti-aromatic one. As aromaticity will stabilize the compounds, the release of this first hydrogen will be faster, whereas the release of the third hydrogen will be very much delayed. If this hydrogen is lost, that makes no big difference. That's why it is moderately acidic. So that's why option B is the right answer. The order of acidity of the following compounds is, the right answer is A. It's because of ortho effect. We know that the benzoic acid is a resonance hybrid and hence the carbonyl group is coplanar with the ring. An ortho substituent tends to prevent this coplanarity, hence resonance in the carbonyl group is prevented and hence OH group is greatly polarized. This results in increased acidity. Okay. Third one, the correct order of acidity of the following is, the right answer is B. We know that electron withdrawing group will increase acidity, whereas electron donating group will decrease acidity. And we know that NO2 group is both minus I and minus R group, which will always increase acidity, right? Whereas methyl group has plus I effect and it will decrease acidity. Okay. Now in the third compound, NO2 group is present at the ortho position to OH group, which means it will have maximum minus R effect, maximum minus I effect and minus R effect. As minus I effect is directly proportional to the proximity of the electron, H plus releasing group. Okay, so here minus I effect is greater and minus R effect. Whereas in the second compound, the same NO2 group is present at the para position to OH group, which means it will have lesser minus I effect as well as minus R effect. In the fourth compound, NO2 group is present at the meta position, so minus I effect will become null and void and it will have only minus R effect will become null and void and minus I effect will only be there, whereas this methyl group will have a plus I effect. And in the first compound, again NO2 group is at the meta position, so only minus I effect is observed, whereas you have two methyl groups, so this compound will have maximum plus I effect. That's why the order. Fourth one, the right order of acidity is, so the correct answer is B. It's because the conjugate base will be stabilized by resonance for the first compound. First compound's conjugate base will be stabilized by resonance, whereas no such resonance is possible with these two compounds. Okay, these two compounds will not have such resonance. It's only based on the electron withdrawing group. Okay, fluorine's electronegativity is much greater than chlorine, so its minus I effect is much greater than minus I effect of chlorine. Fifth one, the correct order of acidic compounds is, so the right answer is A. It's because electron donating group will decrease acidity, right? So the electron donating nature of this methoxy group is much greater than the phenoxy group, which is much greater than the methyl group. That's why the order. Now, sixth question. The order of acidity of hydrogen is, the right answer is D. It's because this OH group, this COOH group will have greater acidity thanks to the OH group which is present adjacent to it at the ortho position, and that's why ortho effect will operate. Okay, so this is most acidic. And the second one is this carboxyl group, because it is present at the alpha, in the alpha position. A phenyl group is present, which is electron withdrawing group, whereas the same phenyl group is present at beta position for this carboxyl group. That's why this is least acidic. Thank you guys. Happy learning.